Well, students, we're going to go through beginning of chapter 6 now. So what we're going to go into, actually, we'll still be working with probability, but we're going to look at what we call probability distributions. So if you look at like what we've talked about before, let's say I'm rolling a dice, okay? So if I have a dice, okay, on a dice, there's 6 numbers. So you can get the number 1, 2, 3, 4, 5, and 6, okay? When we talk about the probability of getting a number, okay, so we've talked about it in generalities. But if I were to say, okay, so there's a distribution. These are all of the numbers I could get. If I say, okay, what's the probability of getting a 1? So that would be 1 out of 6, okay? Or this would be 0.16 repeating, okay? And it'd be the same for all of them. So the probability of getting a 2 would be, about 17%, a 3, 17, 4, 17, 5, 17, and a 6, 17, 17%. So they'd all be the same in this one. And so that's what we're looking at. So we're going to look at a random variable, okay? So whatever thing we want to look at, that's what we're going to find the probability of, okay? And we're going to look at like all possible outcomes. So here's an example, okay? So let's say we're flipping 2 coins, okay? And we said, okay, what's the probability of getting a heads, okay, if I'm flipping 2 coins? Well, if I look at what's the possibility that could happen, okay? So here, okay, if I look at what are the possibilities, okay? So the possibilities are me getting a heads and a heads, okay? I could get a heads and a tails, or I could flip that around. I could get tails on the first one and a heads on the second one, or I could get tails and tails. So then we say, okay, we want to know what's the possible x, okay? The variable we want to know is what's the probability of getting heads, okay? So if I say, okay, what are the possibility of getting heads? So what it could be is I could get, so heads, okay? I could get 0 heads, okay? So if I got it, okay, I could get 1 heads, or I could get 2 heads. And then we say, okay, what's the probability of getting no heads? That would be 1 out of 4, or that would be 25%. What's the probability of getting 1 heads? Well, that would be, there's 2 of those, heads, tails, or tails, heads. So there's 2 out of 4, and that would be 50%. Or I could get 2 heads, and that would be 1 out of 4, which is 25%. One thing to notice, 25% plus 50% plus 25% equals 100%. And that's what it has to be. Anytime we have a probability distribution, they have to add up to 100%. Okay, so probability distribution just describes the probability of getting a certain outcome. How many times does 5 show up? Or like, as you go through it. So you could look at dice or cards. What's the probability of getting an ace? What's the probability of getting a red card? So we could look at all those distributions. Now, one thing I want you to point out, okay? So keywords, at least, what's the probability of getting at least 3 would be 3 or more, okay? So if you think about it, that's what it's saying. It's saying getting that value or more, okay? More than means we're not including that value, okay? At most means we're at that number, okay? That's the biggest number we could get. So if I said at most 3, it'd be 3 or less, and that's where you see here, less than that number, okay? Less than that number means we're just not going to include it. So if we said less than 3, then we'd say it's 2, 1, okay? Now, here's the key between it. Between, if I just say between, or if the question asks what's in between, we don't include the numbers on the outside. So let's say I have numbers 1, 2, 3, 4, 5, and 6, and I say, what's the probability of getting between 4 and 6? There's only one number that fits between 4 and 6, and that would be a 5. So that's what it's saying, okay? So if it doesn't say, so the difference between this and inclusive, okay, if I said what's between 4 and 6, we would include 4, 5, and 6, all the probabilities of those. So inclusive means include those numbers on the outside. Between just means what are the numbers between it. Don't include the numbers on the outside. So our rules for probability is any probability can only go from 0 to 100%. And if I were to add up all the probabilities, all the distributions, they have to add up to 100% or 1. So here's an example. Company sells ballpoint pens, okay, in bulk packages and the warehouse club wants to have a picture of how the number of defective pens. So this is saying is the probability of having a defective pen. So the probability in that bulk with all those pens, those bulk packages, the probability of having 0 defective pens would be 0.3, or this would be 30%. So this is 30%. Having 1 defective pen would be 21%. 2 defective pens is 12%. 3 defective pens is 10%. 4 is 10%. Okay, 5 would be 9%. And 6 defective pens would be 8%. Now, a couple things to point out to you. These should add, okay, all these numbers should add to 100%. If they don't add to 100%, they're incorrect. So you could add 30 plus 21, that's 51%. Okay, so I can kind of cancel that off. Add 9% to it, so that's at 60% now. Okay, I add 10 and 10. Okay, that's at 80%. All right, I add 12 and 8, that's 20% added to it, so that gives me 100%. So just to point that out to you, all those percentages have to add to 100%. If they don't, then it's wrong. So it says, find the probability of 0 pens being defective. So I look at 0 pens being defective, that would be 30%. Okay, so I'm going to erase that. Okay, what's the probability of more than 3? So more than 3 would be bigger than 3. So we'd find what's the probability of 4, 5, and 6. All right, so I add that, so 19%, so that's 10% plus 9%, that's 19%, plus 8 more, so that would be 27%. Next one says, what's the probability that there's at most, so that would be the highest it could be is 4 or less. So we can go down this way. So we would add 30% plus 21% plus 12% plus 10% plus 10%. And so if I added all those together, that would give me 83%. So again, because I added 30%, 30 plus 21 plus 12 plus 10 plus 10. All right, so 30, that's 50, 51, 63, 73, 83. Find the probability that the number of defective pens is between. So when it says between, it doesn't give me any, it doesn't say inclusive. So I'm just saying, what are the numbers between 2 and 5? The numbers between 2 and 5 are 3 and 4. So 10% plus 10% would give me 20%. And then lastly, find the probability that the number of defective pens is between 2 and 5 inclusive now. So inclusive means we are going to include 2 and 5. So there is a difference between question 4 and 5. So 12% plus 10% is 22. 32 plus 1 more is, or 9 more would be 41%. Okay, so that's what you're going to go through. Again, pay attention to those key words. I would reference you back to this. If you struggle with what's at least or more than or at most or less than, between, inclusive versus not inclusive, then I would have you go back and look at these and go through these ones. So that's our lesson on